Yeah, good morning, everyone. So, myself, Srikantarao, Assistant Professor, Department of CST, MITS, and today we are going to have an introduction topic called OSI model in computer network subject. Okay. So first, we'll see what is OSI model and what are the different layers of OSI model and what are the different layer functionalities. So these things we'll see today in a short introduction video. So now what is this OSI reference model? Basically this OSI reference model is a standard reference model in the network architecture. Okay, OSI means open system interconnection. So basically it has 7 layers. Basically it has 7 layers and each layer has its own functionalities. So generally any network tasks has lot of functionalities, lot of services as to offer. So basically in this model we have seen 7 layers. What are the 7 layers? So let's see. First, later we'll see the functionalities. So before that, we'll see first how the diagram or the architecture of OSI model looks like. See, this is what the architecture in this diagram. So here, first layer is physical layer, second layer is data link layer, third layer is network layer, fourth is transport layer, fifth is session layer, sixth is presentation, and seventh layer is application layer. And one important thing you should make a note here is the layer numbering should be from bottom to top. That means physical layer will be 1 and application layer will be 7. Okay, and see, this is one side is 7 layer, that is the sender side, and receiver side also same thing, all 7 layers will be there. So one side is 7 layer, other side is also 7 layer. In between there is a 3 layer. I'll explain why it is 3 layers only in between. That is the intermediate layers or intermediate systems layers. Up to the message will go up to third layer only. That's why they are showing only 3 layers in the intermediate systems right now. So we have seen these 7 layers, and now we will see what exactly each layer will do. So we'll see the functionalities, devices, and important protocols in that. So first layer will be physical layer. So physical layer basically primary responsibility to transfer the bits from one computer to another computer. Okay, so basically this physical layer will be uh, used to transmit the bits from one system to other system. And other one important task of physical layer is to manage the cables. That means we have lot of cables like UTP cable is there, twisted pair, okay, coaxial cable, optical fiber, copper wire. These are all different cables are there. No? So in order to get the things done from cables and all medium issues, okay, whether it is simplex duplex and what are the voltages, so these things electromechanical things will be taken care by the physical layer, right? So next important layer is called data link layer. So in this layer we have main functionality called framing, error control, and medium access control, also called as MAC. So here what is the meaning of framing? So framing means, frame means what? Basically it is grouping of bits. Okay, grouping of bits is called frame. Here you need to mark from where is the beginning of the frame and where is the ending of the frame through some special techniques like bit stuffing and byte stuffing concepts. Okay, so here we need to identify and differentiate the framing bits also, control bits also here. And second one is error control. Error control involves two important things. One is error detection and other one is error correction. Both tasks will be involved in error control. Error detection means we need to detect whether error is present or not. I don't know where it is. Okay, I don't know how to correct. That is what error detection will do. And error correction means what? It will detect and correct as well. Okay, for example, error control, in error detection we use CRC code. Okay, CRC, cyclic redundancy check bits. And for error detection and correction we have Hamming code algorithms. Okay, so we have two main algorithm here. One is CRC for only detection purpose, and Hamming code is for multiple purpose like detection as well as correction. Here only important thing you should make a note is Hamming code will correct only single bit errors. Okay, then MAC layer. Basically, this data link layer deals with the Ethernet. Then here simultaneously some systems wants to transmit means collision will happen, collision of frames. So that's why we should be very careful about this sending. So data link layer will always have a look into that medium access control. Okay, that means at a time only one person has to send. Okay, so for that we have some different protocols like CSMA bar CD. Okay, so CSMA bar CA, other things also there to control the collisions. Next, we'll move on to the third layer, something called network layer. So network layer is also an important layer where it deals with three main things. One is addressing. See, addressing means for any system in order to identify, like people means people has name, student means they have roll number, like that any system has IP addresses to identify them globally, right? IP address is basically 32 bits, and we have total 5 class of IP addresses. One is class A, class B, class C, class D, class E. Okay, so in that normally we use first three categories for general purpose. And second important thing of network layer responsibility is to uh, routing applications. So routing means basically we have to find out, means routing algorithms will find out the best route to deliver the packets. So that's why there are many types of algorithms in that routing algorithms. So we'll see later what are all those. First, initially, the main primary duty is to routing the packets. Okay. Third one is the congestion control, because this is just like a signal where traffic will jam will happen. Na? Like that only here also in the router, there will be a congestion of packets which are arrived from the different destinations. So here, basically, how to control like our traffic jam in the normal real life, how traffic jam will happen, what are the things we need to have to in order to control those traffic jams. Same concepts here also we are using in the network congestion. So those congestion control algorithms also will place an important prominent role in the network layer. Next will be fourth layer is transport layer. This is like end-to-end layer. We can call it as end-to-end layer. So here, whatever end-to-end layer means what? Here, whatever the activities will happen in the beginning, okay, in the sender side, and the same activities will happen in the receiver side also, not in between. Okay, that means intermediate system is not related to that. Only source and destination will do that activities. Okay, so that is something called end-to-end layer. Okay, it handles both error recognition and recovery also. Okay, and segmentation and reassembly. Okay, segmentation reassembly means if the packet, okay, if the data is large enough to accommodate in one packet, means obviously we can divide that packet into multiple packets, and at the end we can combine, we can reassemble it. Okay, so and this transport layer we have two main protocols, something called TCP and UDP. So TCP means transmission control protocol, UDP means user datagram protocol. Okay, we'll see more on that protocol. And session layer. So session layer is a fifth layer. So here it will do three main tasks. One is dialog control, second one is token management, and third one is synchronization. So dialog control means who has to transmit, okay, who has to transmit, whose turn it is. So token management means those who are having token, so they can transmit. And synchronization means when the system has in error condition, then it has to restart with the same synchronization where it continues from the last error position. Okay, so this is what the main tasks of session layers. Okay, next we'll move on to the presentation layer. So presentation layer will do main tasks like it is basically translates the different data formats because we are dealing with different networks, different countries, different people. So that time data representation and their standard format will be different. So this presentation layer will convert from one data format or one syntax to other syntax so that one universal uniform format will be followed so that everyone can understand. That is one thing. Second thing is we need is data security. So that's why it will do data encryption also. And sometimes data is large means we need to decrease the size so that you can transfer that file easily. So that uh, we have to do data compression. So one thing is exchange of uh, exchange of syntax or data formats to different formats. Second one is data encryption. Third one is data compression. So these three activities are present in the presentation layer. And next layer will be next layer and last layer will be application layer. So this is the important layer where all our user activities will be laid on. That means application layer contains the main application layer protocols like HTTP, FTP, SMTP, okay, Telnet, etc. So whatever we are doing in the daily activities, okay, whatever we are doing in the daily activities like browsing, file transfer, email, okay, remote login. So these are all activities. So we have a different protocols like HTTP basically used for browsing purpose, and we have FTP for file transfer, similarly SMTP for email, so Telnet for remote login. So these are the common protocols. All tasks are present in the application layer protocols. Okay, so this is what the main brief introduction about the OSI layer. In the next session, we will see more on this protocols and their devices, port numbers, etc. Thank you.